Hey everybody, this is Mr. T. I'm going to demo the card that Errol and I worked on for OTA to an ESP32. Here I've got a ESP32 attached to a breadboard that's running a blink sketch that's blinking the onboard LED once per second. I've got a USB cable plugged in, which is attached to a phone charger, which is attached to a power cord. So you can see that I don't have any physical connection to the computer. What I intend to do for this demo is to flash this chip with a different program that will turn the LED on and off once every 2 seconds instead of once every second. So let's take a look at that sketch first of all. That is here. Okay, so I've got this basic OTA sketch which came from the examples when I installed the Esp-32 dev module into the Arduino IDE. And I feel it's important to clarify here that when we speak of Arduino, that can actually mean an Arduino board like the Uno or the Nano, or it can mean the Arduino development ecosystem, which is capable of working with multiple controller boards, including the ESP32. So when I installed the support for the ESP32 dev module, I got all of these demo sketches, including the basic OTA. And I've modified the basic OTA home network credentials. This is a little bit of code here for manipulating the onboard LED. The setup function runs one time when the device is powered on. It's going to turn on the serial monitor, which is actually going to fail silently because I don't have a USB cable connected to my computer, so there's no way to actually look at that because the device is running independently of a host computer. This line sets the LED to output mode so that I can actually output to the LED to trigger the on or off state. This block here is going to connect to my home network. And I've been really lucky to get a sticky IP address that I can depend on for the purpose of this demo. This block of code here is a kind of cool builder pattern event driven model where I can specify the behavior for different states of the OTA process. And I actually didn't modify any of this code. This is all straight out of the box from the demo. Then once I begin, it's going to display my IP address through the serial monitor. And again, I can't actually see that because I don't have the ESP connected to my computer. I'm just depending on the behavior of my router to give me the same IP address with every reboot of the system. In real life, at this point, what we would probably want to do is hit a web endpoint, likely through an HTTP put, that would store the IP address of the device in the current running software version. So that way a separate program could take a look at all the devices out there in the wild, look at which ones need to be updated, and then attempt to do a push of code to those devices based on that device's IP address. Okay, now I've got this loop that runs continuously. The first thing it's going to do is run the Arduino OTA handle, which is going to check if there's an incoming software update request. And I'm not particularly happy that this is inside the loop. I would prefer that that would be done through a timer interrupt, so it's a little bit more seamless and doesn't kind of pollute my main loop with code that's not part of my business logic. Okay, the remainder of the code here is going to check if the LED needs to be toggled, and if so, it goes ahead and does that toggle. And this code is intended to loop very quickly so that we don't miss the request to update the code. And I believe if that was done through a timer interrupt, we wouldn't have to worry about how long the main loop actually runs, but I haven't spiked any of that out. Likely won't, because I believe we have higher priority cards in the backlog. All right, so let's demo that. So here in Visual Studio Code, I've got a couple of images, binaries, that one that will run the LED, what I call fast, which is once every second, and what I call slow is once every 2 seconds. Okay, and then I have corresponding scripts that will do the actual flash. So this is going to source my environment script and then run the tool at the appropriate IP address and send over the appropriate binary through my router. In real life, what we would like to do is to ping a web server that has the information of the devices that need to be updated because their software version is old, what the IP address of that device is, and then go ahead and try to update any that need to be updated. So my ENVSH that gets sourced points to where my Esp-OTA tool is installed, which was part of the Arduino libraries when I installed the Esp-32 hardware into my IDE. So again, when I'm speaking of Arduino here, I'm not speaking of a Uno controller or a Nano controller. I'm speaking of the Arduino development ecosystem. Okay, and this is the sticky IP address that my router has been nice enough to give me. Okay, let's try to run this. Right now my fast blink is running. I'm going to run my slow blink script. Okay, so right now my LED has been forced to an off state. It could have been just as likely stuck on the on state. Now the upload is done and it's rebooted the chip, and now I'm blinking slow. So I've updated the program successfully. Let's put it back and put the fast version back on there. So I'm going to run my fast blink script. There we go. And now my LED is stuck on. Program is updating. Oh, and I got an error response. This is very good. I didn't intend to put this as part of the demo. And this is very interesting that even though the upload failed, the previous program is still working, which is something I didn't expect. I expected the device to actually be bricked. So this is actually very good. Let's give it one more try. Now my LED is stuck off. Successful upload, and now it's blinking fast again. And again, the device isn't connected to a computer, it's just connected to a power cable. It could have just as easily connected to a LiPo battery. And that concludes the demo. Have an awesome Friday and a great weekend. See you guys Monday. Take care.